All right. So again, my friends, I would like you to double check your work. Make sure you feel comfortable about it. If you have a question about it, any of these problems, let's make sure we have them answered, okay? All right. So problem number 1 is root 5 plus 3 root 5. So one thing I wanted to point out, and I didn't point it out to it last week, and I apologize because I'm not a good teacher. Do you all feel comfortable there's a 1 in front of that? Does that make sense? And I know that sounds funny, but every now and then there's going to be someone who you forget it. And so I just want to point that out. So we're adding these. So that just means we count them up. So I'm going to add those. So I'm going to get 4 root 5. And that's the answer. Okay, we don't increase the radical. We treat the radical like it was like an x or something like that. Okay? And then problem number 3 is 4 root 20 plus 2 root 45. Now, does everyone feel comfortable that we cannot add these together as they sit? Does that make sense? Because root 20 and root 45 are not the same radical. Now, it's very possible we could break the radicals down. So I think I could break this down to 4 times 5. And the reason I'm choosing 4 and 5 and not 2 and 10 is because 4, oh, they erased our perfect squares. Is because 4 is our largest perfect square that works. Okay, so what's the square root of 4, friends? 2. 2 gets multiplied by this 4 out here, so I get an 8. So I get 8 root 5. Agree? Plus, what do you want to break 45 down to? 5, 5, and what?
5, 5.
Nope. 5, 5, and 3 would be 75. Yeah. 5 and 9 I like. The 9 is a perfect square. That's okay. It happens. So we have a 9 here. So the square root of 9 is 3. And that 3 does what to this 2? Get multiplied. So I get 6 root 5. So now, friends, are these like terms? I realize they're different colors, but are they like terms? The root 5s are the same. I can go ahead and add. So 8 added to 6 is 14. The root 5 comes along for the ride. Again, we do not improve the radical at all. And again, we've talked about these. These are exact answers. And my friends, the more exact answers that are happening out there in industry, the better all of our stuff works. Imagine the day when your cell phone would work in this classroom.
Never.
It could happen though. One day. I might be teaching your kids if I'm still teaching. Oh. All right. My wife asked me, she goes, when do you think you'll retire? And I said, when I stop having fun. She goes, you still having fun? I said, yeah. She goes, good, you're not retiring. Yeah, I'm going to be one of those teachers. I'm going to be like, any of you have Coach Moose for PE? She's been here for like 641 years. Yeah, she's like 39 years teaching in this building. Like crazy. Really? Oh my gosh. The only other person who's been here longer, but he has retired, but he still coaches, is Coach Johnson, our baseball coach. I think this is his 48th year coaching baseball at Cherry Creek. How much? Was it different? Was it 48 or? Oh, I thought someone said something different. No, I think it's his 48th. I mean, it's crazy. I don't know if any of you know Coach Johnson or not, but I'll tell you that is an absolute legacy. That's great. If I'm here for 40 years, oh boy, that puts me in my 80s. Well, you know what? I got to be honest. Y'all keep me young. I appreciate that. You're looking out for my youth. I appreciate that. I couldn't thank you any more for that. Hey, friends, is root 36 a perfect square?
Yeah.
So what's the square root of 36? What does it do to that 2? Multiply. So I get a 12 there. Hey, where'd the radical go? Well, the square root of 36 is 6. There's nothing left behind on that one. Okay, so plus, and then I'm going to break 12 down. I'm going to break 12 down to 4 times 3. I'm using 4 and 3 and not 2 and 6 because 4 is a perfect square. Agree? Yeah. Nope. Square root of 4, friends. 2. 2 does what to this 3? So I get 6 root 3.
12 root 3.
Hey, friends, can I go any further?
Yes. 18 root 3.
Uh-uh. The 12 doesn't have a root with it. They're not like terms. That'd be like adding x and y together to get xy, because that's a big no-no in math. All right. I'm feeling okay about this stuff so far. Number 7, I get 3 root 7, and the whole thing is squared. So how many 3 root 7s are we talking about here? 2 of them. Agree? So I get 3 root 7 times 3 root 7. And we're multiplying now. When we multiply outside, outside, which gives me 9. And we multiply inside, inside, which gives me 49. Now, friends, being I multiplied the same number together to get to 49, what can you guarantee me about the number 49?
It's a square root.
Square root. Square root of 49 is?
7.
So I get 9 times 7. 9 times 7, I believe, is 63 this week. Next week, it might be different. Again, where did the square root go? Because we had a perfect square, it went bye-bye. Make sense? Everyone? What happened?
Bye-bye.
Bye-bye. Yeah. We took it out. It's gone. We did the operation. All right. Anything that I've gone over so far of these 1, 2, 3, 4 problems that we've worked out so far? Feel comfortable with that? So when we add or subtract, we have to make sure the radicals are the same, so we combine the outside. When we multiply, we can multiply the outside numbers and the inside numbers and inside numbers. So there's a difference between add and subtract and multiply and divide. We're not dividing these at this point, but there is a difference. Okay? Don't worry, we won't be dividing it, so don't get that sinking feeling going, I don't like division. This one is this. So, my friends, this is a distributive problem. So we have to understand that there's a 1 out in front of there. Agreed? If I multiply these, I get 3 times 1, which is 3. Root 5 times root 2 is root 10.
Or you can do that like 5 times 2.
Yeah, I definitely could. I think I'll keep it together for right now, but I think I like your thought on that. Plus, 3 times 3 is 9. Root 5 times root 5 is root 25. What can you guarantee me about root 25, my friends? Yeah, perfect square. Square root of 25 is? So I get 3 root 10. Square root of 25 is said is 5. What does that 5 do to that 9?
45.
45. Notice, the only thing that has a radical is the first part. So I get 3 root 10 plus 45. That's it. That's all we're doing, right? Everyone feel comfortable about this? Oh, the square root of 25 is 5. Thank you so much. And then 5 times 9.
Thank you.
Appreciate you. I'll get this in the grade book at the end of second period because I'm off second. Sound like a deal? Cool.
Thank you.
Thanks. All right. Can I go to number 11? Number 11. Actually, I'm going to go number 11 on a whole separate screen. So I get this. So this is a FOIL situation, a double distribute. Okay? So I'll just color this up. So I'm going to go 1 times 1 gives me 1. Everyone feel comfortable so far? Then I'm going to go 1 times negative 3 is negative root 3. Agree? Then I'm going to go 3 times 1. That gives me plus root 3. Hey, is there a 1 in front of those?
Yeah.
Yeah. And then the last part is going to give me root 3 times negative root 3 is negative root 9. So are these like terms? Yeah. They're opposite value because one's positive and one's negative. Agreed?
How do you root the negative?
Oh, we're going to get there in a sec. So does everyone feel comfortable those cancel out?
Yeah.
So the 1 comes down. Minus, hey, what's the square root of 9? 3. And as long as that negative is outside, it's fine. You just bring it along for the ride. But then you get 1 subtract 3. In this case, we just get negative 2 for an answer.
So you went in after find the square root of a negative.
No, the square root of a negative is actually something that's part of the complex number system, which is a larger number system than the real number system, which you're dealing with. In fact, this has an imaginary component to it because you have an imaginary part, the square root of a negative. And I kid you not, they named the number system imaginary. And what's funny is, so, you all learned the counting numbers like in kindergarten. Like, hey, you have 2 apples and you have 3 more apples. How many apples do you have? Count them up. 1, 2, 3, 4, 5. I got 5. That's the counting. And then you got advanced. They changed it to the whole number system. The whole number system is the counting numbers with 0 added. I mean, it's like this, so improved. And then it got to the integers, which was the negative numbers and the positive numbers and 0. And then you got to, they started saying decimals and fractions. Those become rational and irrational numbers, depending upon if the decimal terminates or not, or repeats. So then you have rational and irrational. So all of those number systems I just said to you just now, the counting numbers, the whole numbers, the integers, the rationals and the irrationals, they're all part of a really big number system called the real number system. And then they go to the imaginary. So, I had a parent a couple years ago, he called and he goes, "Why are you teaching my child about imaginary numbers?" I said, "Because that's one of the number systems." And he goes, "But they're not real." I said, "You're absolutely right. They are imaginary numbers. But how can they be imaginary if imaginary are imaginary?" Well, imaginary takes place when you have a negative radical. Yeah, but they're not real. That's correct. So he's using all the terminology of the names of the number systems. But I'll tell you what, some math people back in the day, they were mean, cruel, cruel people. They were like, let's start naming things so people will get all confused. And I think the whole math world needs to get together and say, let's start naming stuff, these unfair, uncool, horrible names. So now we do have a fraction here. Okay. So, square root of 144. 12. Square root of 81. We feel okay so far? This is even, yes? This is an even number. So what's the square root of x to the 6th? X to the 3rd. I'm going to break this down to y to the 2nd times y to the 1st. So what's the square root of y to the 2nd? Y, and then I'm left with this square root y here. So then, and I wouldn't give you something like this on the quiz. We got a quiz coming up sometime next week. 12 over 9. I think 3 goes into both of them. So I get 4 on top. I get 3 on bottom. And we're pretty much there. We don't have to do that. We can just keep it. Just keep it. Okay. So 15 kind of follows the same suit as this one. 15, we get this. The nice thing is we're not going to be left with any radicals, I don't believe. All right. Square root of 16 is? Square root of 49 is? Square root of y to the 4th? Square root of x squared? There's my answer. No radicals on that one because we had perfect squares. And then 17, we are going to skip. We're going to skip 17. Because I'm just going back and looking. Oh, actually, we're gonna do 17. I'm gonna do 17 on the next one. Oh yeah. All right, so let's see who can think back to last week's math. Yeah. Root 2, top and bottom. So on top, I get 8 root 2. On bottom, I get root 4. What's root 4? 2. 4 root 2. Because it'll reduce outside, not outside, inside. The root 2 can't come outside to play. Okay? And I'm not going to worry about number 19 and number 21 and number 23. I'm not too worried about those. I'm okay. So my friends, I would like to give you all the opportunity to finish SQE number 5. So get the evens done. So that would be, let's just make sure we do 2 through 18. Okay? If you need a picture of it, come take a picture of it. If you already have it, if you want to do it on a separate sheet of paper. But what I'll do is I'll come around the room and help you. If you have anything old that you need to show me, bring it on up and we'll take care of it. But I'm going to stop recording. What's that?